Hello and welcome to another Into the Terminal. Today we're going to be talking about Podman.
I like Podman. One of my favorite
Okay.
features of RHEL. I don't know why, but it is. I just love it.
Everyone loves Podman. But I know we've covered containers in the past. And if you're interested in what we go into like create containers and other stuff, there's plenty of other episodes for you to take a look at. But we wanted to start today with just like Podman basics. So like you're new to containers. What do you do with Podman, right? So we're going to cover things like getting a container, running a container, different options for running a container, taking a look at what it's behaving like on the system. So those types of things. Nate, do you want to get us started by jumping into the terminal?
Sure thing. All right. So this time, I mean, we are literally starting with a basic RHEL system today. I don't even have Podman installed yet. So the first thing we're going to cover is how the heck do you install Podman? And it's actually really simple. There was on RHEL 9 and older a meta package called Container Tools, which would install Podman and a bunch of other things. You don't necessarily need all the other things, so that doesn't exist in RHEL 10 anymore. I happen to be on a RHEL 9 system, but I'm going to give you exactly what you would do on 10 as well. And that's just DNF install. We're going to add the -y just so we don't have to tell it yes. And Podman. And Podman, there's two cool things about Podman. I mean, there's a bunch of extra features in Podman that don't exist on the Docker side. But if you're coming from a Docker background, the command line interface for Podman is practically identical to Docker, which is, I think, really cool. And the other thing is we can run things without root permissions, which is Docker runs as root because it uses a daemon. So we're going to do at least all my demos today as a standard user. So we're going to just standard RHEL user. The user does have sudo permission, but we're not going to use it in this particular in any of the demos today. So here we are. We've got a brand new system installed with Podman, right? There's the Podman CLI. We're going to just run something and kind of give you a little bit of a walkthrough of what a container kind of is and what it looks like to just kind of interact with one. So let me get my command line here. So we're going to run a Podman command where we're going to pull in a container and run it, a container image and run it. We're going to talk more about all these things in the deeper dive. We're going to run it interactively. That's what the -it flag here is doing. And the reason I'm running this particular one is because it'll just get us a shell within the container, right? And I want to kind of show you what it feels like to just kind of operate inside of a container. So here we are. It pulled the container or it pulled the image from Red Hat's public registry and it ran it. And now it looks like we're root inside of a Linux system, right? Now, remember, we ran this as a standard user. I was that RHEL user. And you could see from the prompt there, right? $, that was a standard user. Now we have a root prompt within our container. Now, you might say, well, that feels like you're in a virtual machine. We're not. And again, we'll talk about that in a little bit too. So here's how things are really similar, right? So I have a Linux file system. You can see I've got like an Etsy directory. I've got a password file, kind of, the stuff that you'd expect to find inside of a Linux system. What I don't have in this particular one is an init system. Systemd is just like not even running, right? The tooling is there, but it's not running at all. And that's because the container that I chose to run doesn't have an init system, because a lot of containers, when you run them, do not run an init system. You literally tell the container image what it's supposed to run. And, again, we'll talk a little bit more about that in a minute, but I'm going to give you a little bit more of a realistic demo here. That was just to kind of show you it's a container, right? It's a Linux system, but it's not really a Linux system. It's more like a walled off garden that has its own file system and its own feel like a Linux system, but it's not a full system, right? All right. So what we're going to do now is we're going to actually pull in something that does something other than just get us to a shell, and we're going to run that. So let me grab that one here. All right, now we'll talk a little bit more about what registries are and whatnot, but what we're doing here is we're using Podman to run an image that's on the Docker Hub public registry. And the reason we can do that is because Podman and Docker are both OCI compatible or compliant container runtimes. OCI is it's a standard that basically says what a container should look like and how it should operate, right? And because Docker and Podman both respect the same standards, they can both run the same container images. So here we are. We're going to run an Nginx container. If you're not familiar with Nginx, it's a web server that can also be used as a proxy server. We usually use HTTPD, so I'm mixing it up this time. All right, so it's running, but we're just back to a prompt. What does all this mean? Well, again, you're going to have to stick around to the deeper dive to find out kind of where that went and how we interact with it. But what I will show you, notice, and again, we'll dive into this command in a minute. I told it to map port 8080 to port 80 within my container. So now if I use curl on localhost, and you can map this to specific IPs or public IPs if you want to, because that's, what's the point if it's only local. On port 8080, there we go. This is the Nginx starter page from the container that we pulled and ran. So now we have Nginx up and running within a container. And we're going to go a little deeper, not too deep, this is basics, remember, on everything we just touched on and what these images are and all of that in our deeper dive.
Yeah, so we'll also be talking about those options that you used with your Podman command and what they do. We'll talk a little bit about what a container is, kind of what's contained within the container. A couple more examples, and then we'll be doing a bunch of different options and command line arguments for Podman for working with containers and images on the machine. So this is normally the time where we would do the swooshy swoosh and go to the deeper dive. But we're going to try something different today because Nate and I were talking about how a lot of other Linux shows, they'll do a 30-minute episode, but I feel like only 10 minutes is actually on the thing, and 20 minutes is like hawking services and swag and other things for their channel. So we're going to do that. We're gonna hawk a product for our channel today instead of the swooshy swoosh. All right, so here we go. Our super fake sponsor today is Nate's Artisanal Beard Care. For a scant $1 million, you can have Nate come to your house and he will trim and dye your beard any color you want, as long as it is blue. Did you know that Nate has tremendous beard shaping skills? It's almost like a topiary. You can ask Nate to shape your beard like a bird in flight. Perhaps a giraffe. Maybe you want something more shapely. So maybe it's just like a bunch of stacked diamonds. Or possibly you love sci-fi and you want it to just be shaped like an astronaut sticking off the bottom of your chin. You never know what you'll get with the super fabulousness of Nate's Artisanal Beard Care. Don't forget that every visit from Nate also comes with a super swanky beard bonnet for wearing to keep your beard nice and contained while you sleep. You may see that in some of our other promotional videos at some point in the future. All right, so that's Nate's Artisanal Beard Care. That's our super fake sponsor this week.
For $1 million, I might do those things. Just saying.
All right, so we're going to return to the actual content, which is podcast, and we'll see what next week's super fake sponsor is going to be. All right, so Nate, transitioning to the deeper dive. What is
people miss the swoosh? Do we need a swoosh?
What is a container, and why wouldn't you just use our virtual machine?
All right, so I already sort of made this parallel between a container and a virtual machine, right? They're not the same thing. There are certain circumstances where you may be running a container in a virtual machine, but we're not going to get into that because that gets into deeper stuff than we're talking about here. At its base, a container. So I guess here, let's talk about a virtual machine first. Excuse me. A virtual machine is an actual machine with a virtual processor and virtual memory isolation and all of that running inside of memory. And it runs its own init system and it runs the entire system virtualized, right? It has very little dependence on the host operating system. Obviously, the host operating system has to be able to run a virtual machine in order to be able to run a virtual machine, but it kind of ends there. It's a completely isolated thing. It is a virtual machine, right? It is all running in memory. It's got all the overhead of a full machine, right? And if you run several virtual machines on a machine, on a hypervisor, all of them have their own isolation, their own memory footprint and whatever, and they're just heavier, right? With a container, instead, what it does is it shares the environment, maybe not the environment, it shares the kernel and memory and CPU slices and all of that from the host operating system and just containerizes or isolates those things using things like SE Linux and C groups and whatnot, so that when you're running a container, things like the kernel from the host operating system are still leveraged to operate or run the things within that container, right? It's not a whole separate kernel. So what you can't do is say my host operating system is on kernel version XYZ and my guest or my container is on some other kernel, right? Because that just isn't the way it works here. You'd need a virtual machine for something like that. Or if you're on a whole different operating system within your guest, that would have to be a virtual machine. But in the case where you're just trying to take services and run them on a Linux host and isolate them from each other, container is so much more lightweight and it's a lot easier way to get that done.
Yeah, and just to like double down on a little bit. So let me show you an example of what Nate's talking about here. So here's my my RHEL host. This is a RHEL 9 host, and I'm just going to run a container that I built before the episode, right? So if I look at my Podman images, uh-oh,
You broke something.
I did.
What'd you do?
I hope I didn't break it.
Maybe you.
Okay, it's running.
There you go.
That's fine.
Okay.
So maybe I just didn't save it into my local registry. All right, so we have this Podman container running, and what's in it is a containerized Apache. And if I look at process status, and I look at just the Apache processes, what you'll see is there's this one here that's owned by the RHEL user, which is the same user I ran my container as. And then there's these other processes that are owned by this weird process ID number. That's actually the Apache daemon user inside of my containerized environment. And why that's important is that because it's running within my container, normally things like the RHEL user process there would be owned by root because it's attached to port 80 on the host. You have to be root in order to attach to privileged ports. But oh, did I forget to show the thing?
Shh, it's fine. We're good.
Okay.
Nothing's wrong, Scott.
Okay, I'm moving on. But because we're running rootlessly, the regular unprivileged user, RHEL, owns the container and is operating as the root user. And then inside of my containerized environment, the users are actually mapped to other random user IDs so that no one on the host operating system is given root authority on the host operating system. All right, but if this was a virtual machine, and I was running a VM and I did a PSAUX and looked for my VM, I would see one entry for the virtual machine. And I would have no visibility into what was happening inside of that virtual machine from the host operating system, right? I would just see that the virtual machine process is running and how much memory was dedicated to it and how much CPU consumption it was doing. And when we do things like C groups where we can group processes together and manage the system resources that are dedicated to them, I could have that one virtual machine managed as a single process. Whereas with containers, I can actually go down and say, oh, HTTPD processes owned by the RHEL user or user ID 2311119 should be managed in this way. And that should be separate from other processes happening on the system. So that's a little bit on like the shared environment. I also wanted to mention what Nate said about kernels. So traditionally, this is actually really hard because different kernels behaved differently.
Mm-hmm.
So you may really, it'd be important that you're running a 2.4 kernel or 2.6 kernel or 5 kernel for your application or workload or whatever your additional binaries were compiled against. We at Red Hat do a tremendous amount of effort to QA our container images so that you can run RHEL 8 containers on RHEL 9 hosts or RHEL 10 containers on RHEL 9 hosts or vice versa. And that's also one of the reasons why, like when we look at our Red Hat officially supported official things, while Ubuntu containers may work, we don't officially support them because we don't do the level of testing and compatibility testing that we could say, yes, this random container that you've pulled down for Ubuntu or Alpine or whatever works with the 5 kernel that comes with RHEL 8, right? Because we don't know what's actually inside of that container image that you pulled down and started running. So generally containers are portable, but not always. And there's some like really weird times where that's been the case. So for Red Hat purposes, we do a tremendous amount of QA to make sure that RHEL or RHEL derived images like the universal base image that Nate and I were using today work on other RHEL container hosts. And if it's not working for some reason and you have a support agreement with Red Hat, you can like ask someone to help you fix it. But that's not the case with what we would term third-party supported things, right? Where you grab a random image and run it. It will likely work because containers are built to be very portable. But there is a small chance that maybe it's incompatible with whatever version of Linux you're running it on.
Right. So we've talked quite a bit about container images, and we haven't really delved into what that actually is. Like, what does it mean when we're talking about a container image? And we've got, there's a couple things to talk about there. The first of all, what's in a container image? And there's really two core things that are in there. One is this interesting layered file system. We'll talk a little bit more about what those layers mean. And the other thing is some metadata, and that metadata sort of defines what your image is supposed to do, how it runs, that kind of thing, right? For example, that port that I mapped in. If I were to grab a random container from some registry somewhere, we'll talk about registries too. What if I pulled in that Nginx container, and now Nginx can be configured to listen on any port. Standard is port 80, so it's a good assumption that it's probably going to listen on port 80. But I could be listening, the container could be listening on some other port. Well, part of the metadata for that image, you can actually query, and it'll tell you, this is the port we expose. And in that case, it would probably say 80, right? And then I could tell it, map 80 in there.
Yeah, so I was just going to show how to do that, right? You can use Podman inspect on the container image that you've pulled into your local repository. And down here,
right there, expose ports.
I was talking about.
Right. So if I'm building a container, which is a whole other topic, but if I'm building my own container and I am publishing it on a certain port, then I don't necessarily have to define metadata that says what port it exposes. But if I don't, then people who use my container will have no idea what port to forward in. They'll have to guess, or they'll have to do some other troubleshooting to figure out where my service listens on. But if I add that in there, then they'll know, oh, it listens on port 80. I should forward my traffic to port 80, right? Also, things like what command it should run. You can see right there on Scott's screen that this particular container, when it brings up that layered file system, it should run this command, and it's going to run HTTPD, and it's going to run it in the foreground. Now, that layered file system is a whole other topic. When you build a container, it's usually based on something else, right? You can build them from scratch, but I've never done that myself. I've seen it done, but basically it's usually based on something. Like maybe we'll base it on that UBI container that I showed my example in. And then you have a set of instructions that tell the system what else to do on top of that base image, right? Maybe you install some packages. Maybe you run some machines or some executables. Maybe you run a script that does some things within the image. And every command that runs lays down a new layer on top of that file system. So the base layer is going to be UBI in this example. And then everything beneath that is going to be another layer. And the really cool thing is, if I make a change at the end of those instructions and then rebuild my container, it doesn't touch any layer until it gets to that command that I've changed, right? So in a world where I'm building an application that I'm putting out on all of my systems, that means that the delta that it has to download when it gets an updated container image is just that layer, which is actually a really nice way of doing things. If you've got a container image that's a couple hundred meg, which is usually about the size of these things, it doesn't sound like a lot of space, but when you're deploying it to 1,000 machines or something, that could really add up, right? So having that layered file system where it's only a couple K of difference is really a big difference, right?
Yeah, and in containers, people will talk about things like the size of the container. And there are two sizes you're interested in. The compressed size, which is when you're transferring it to a new machine, that's how much data is being transferred. And then once it reaches its target machine, it'll uncompress. And then the uncompressed size is how much file system space you're using on that machine that has now received the container image into its local repository. The layer count is important because as you increase the layers, because you're making consistent changes to the container, you're adding disk space to the storage of it, right? Because it's what's called a file system overlay. So what happens is you have your base container, and then if you change a component and that gets stored as a layer, essentially what happens is when you're looking at the container, you're looking at the top layer, which is those files and directories that exist that override the stuff that's in the layer below it, which may override the stuff that's in the layer below it. And so every time you make a layer, you're adding a little bit more space to your container image. And at some point, you may want to just rebuild your container because you want to squish those layers together so there's not all this differential layering. Instead, go back to base container or maybe base container
Right.
plus one build layer. But
Right.
it's around managing the size of the container. That's why people are concerned about things like layer count or layer or container size, essentially.
Right. And that brings us to kind of the last point, which is who makes these things? Who makes these container images? And that, I mean, could be literally anybody. It's really just like any other software packaging. It could be some guy who had some crazy idea for a thing and he published it. It could be publishers like Red Hat or Canonical or whoever, right? If they have an interest in providing container images as bases for people to build from, you could see large companies that sign these things and everything so that you have some validation as to where they came from. But you could just build your own, right? If you have your own custom thing that you need to build for your own needs, then you don't even have to publish it. You can build this right on your laptop or something and then move it around to your own local registry. And I keep saying registry and I keep saying we're going to talk about it eventually. I guess that's a great thing to talk about next. And then I promise folks, we're going to get back into demos soon. A registry is sort of like a software repository, right? So imagine like an RPM repository where I've built RPMs and I put them in that repository so that all of the systems that I manage can go and get those RPMs. A container registry is the exact same concept, except it's made to hold container images, right? So Podman, Docker, a bunch of others, they'll be able to query these registries and pull in container images. And then when you get deeper into this, you have things like pipelines that do automated builds and whatever. Those can also pull from these same registries and push back to them, right? So it'll pull in a container image, do some stuff to build my container, and then push it back to the registry that my systems use to pull in their containers. So this all leads into this whole DevOps lifecycle that is really like the nirvana that container operators are looking for, right?
So Nate, you promised jumping back into demos. Is it that time?
I think it's that time. So the first thing I wanted to touch on was that run that we did at the beginning, right? It's not the one I wanted to show. I wanted to show the Nginx one. Control R, run. There we go. Okay, so we did a Podman run. And run is just like the subcommand for Podman that says we're about to run a container. There's a bunch of other subcommands, start, stop, all these other things. And we're going to talk about those too. But that's sort of the command that brings up this subset of arguments that we have that follow it, right? -D tells it to run this particular container in detached mode, which basically puts it into the background. If I did it with IT, which is actually convenient that I accidentally pulled up that other one first, I have IT in this one. That says to run interactively with the existing terminal. D says, don't show me the output, throw it into the background, and then it'll run in the background. -- name is just a convenient way to tell it, what do I want this container to be named on my system so that I can find it and talk to it later. If you don't give it a name, it generates one, and they're always long and hard to type and really weird spelled, and I don't recommend it. -P we kind of touched on. This is where you can tell it what port to forward into the container. And again, this tells it local port 8080 should go to container port 80. You could also, if you have a system that has several IP addresses, or if you have a specific IP address on the system that you want to bind this particular container to, you could say, 10.1.2.3:8080:80. And that'll say this IP address, this local port, that container port. And I use that on my home lab because I have one system down there that runs virtual machines, and it also runs containers because this isn't an enterprise. This is my home lab. So what I do is I have actually several alternate IP addresses allocated to that machine. And when I run containers that I want accessible, that I don't want to step on each other, I just give them their own IP address, and then I run that container on that IP address. So that way there's no port conflicts and whatever for things that are running that might be using the same ports and whatnot. Okay,
And
so
I did want to point out the port mapping.
Sure.
Stop me if we're going to talk about this in more detail. But because you're using rootless containers, meaning you're running as a regular person,
Yep.
You can't have your container bind to port 80 because that's a privileged port.
Right.
That's why we're using this high numbered port that we are choosing, 8080, and then forwarding that traffic automatically. And what it's really doing is setting up a firewall rule to take care of routing that traffic from this port on the machine's IP addresses to this container and the port that it's reserved for that container.
Right. And then, of course, the last argument I have here is where to find this container in the registry. Now, your system is going to know about a certain amount of registries. Docker Hub is usually one that comes out of the box. So are things like the public Red Hat registries. There are other Red Hat registries that require authentication, which you would have to do a Podman login to get into, but we're not going to touch on that sort of more advanced use case. But if you ran your own registry, you would just basically define that, and then you'd be able to pull from it as well. Or you call it out directly. You could say, like I said, docker.io/nginx. That just tells Podman, I don't care if I know about the registry. I've already been given the address to go get it at. Here's, let me go get that particular container. Okay. And that's that command, but I want to show you a couple other things within Podman that I consider are kind of the basics that you need to know in order to manage containers, right, within Podman. So let's clean off my screen here. So remember I said there's all these different subcommands for Podman. There's Podman PS, which is just like PS. I shouldn't say just like. It's the same concept as PS in Bash, which tells it what processes are running, except in this case, it's, hey, Podman, what containers are running? And you can see here, I've got this list of any running containers. And the only thing that's running at the moment is that Nginx system that I started in the critical path. So you can see right there, that's the name of the container. It even tells me what process it's running, how long it's been up, things like that. There's also a subcommand to that called ps-a, which says, show me all of them, even if they're not running. And I'll be able to show you that as an example after I show you the start and stop commands. The other thing I want to show you while this one's running is there's one called Podman logs. And logs is what you might think it is. Show me the console output from this particular container. Right. So if we do Podman logs Nginx, it's going to show me the output for the Nginx process that's effectively running in the foreground in the container, right? Because that's how this container is written to operate. So you'll see things like the access log in this case for Nginx, because I think the container is configured to send the access log to standard out instead of writing to a log file, or maybe it sent it to both. I don't remember. But at any rate, usually for something like a service, you'll see its active output right there inside of that console or inside of the Podman logs. You can also do a Podman logs -f, which just like tail -f follows the log. So if you're watching for an error or you're watching for access or you're just trying to tell, is my container responding to things, you can use that -f and it'll follow the log for you as requests come in. And then Control-C, like you'd expect, would get you out of that. All right, the next big ones would be, how do I start and stop containers that are already defined? So you might say, well, we already started a container with run. Well, what run does is it defines a container and then runs it, right? We can now also start and stop the container with podman stop, right? And now if I do a podman ps, it won't show it to me because it's only showing me running containers in podman ps. If I do a ps-a, then it says show me all the containers like I mentioned before. And now you can see that it's still there. That means it's still defined. I could start it back up again, but it tells me it's exited 11 seconds ago, right? And it even gives you the return code. So if this thing died for some reason, that return code would be something other than 0, likely. And that tells me something went wrong with this container and it died unexpectedly. And then it'll usually say, instead of exited says like this thing cleanly shut down. I forget what it says. It'll give you a different status there instead of 0, and it'll say something other than exited. Now I can start it back up again, right? Because it's already defined. If I tried to like podman start something else, it says there's no container with that name. So if I were to define a container, it uses the name or the ID. This thing here is the container's ID. You could also use that instead of the name. Again, I don't recommend that. But if you need to be absolutely precise that the thing you're about to interact with is exactly the thing you found in the listing, that's the way to do it. You use that ID. That way it's less likely to be a fat finger typo or something.
So real quick on that. One of the things that containers are known for, Nate, is being stateless.
Mm-hmm.
Right? So you like create a new container. But in this case, when you started a container that had been stopped, what about its state?
So the state of a container will persist as long as it's stuff the container wrote to its local disk, right? Stuff that's in memory, of course, as you'd expect. When it stops, it goes away. But stuff that it wrote to the container, like the disk within the container, the layered file system, that will persist as long as the container isn't removed, right? So if I stop and start this container, then anything that was in that image will come back with the container. Anything that I wrote to the image. So if I had dynamic data that gets written to the file system, in this particular case, it'll persist until I delete the container. But that's an important point, because usually what happens when you want to update this container, say there's a newer version of Nginx or the container had a security fix applied to it, the image back in the registry, what you would do is pull down a new version of that image, delete this container, and start a new one with the new updated image. So that means anything you wrote to that container is actually lost, right? And that can be a problem if you didn't expect it to happen, right? And we'll talk a little bit about how to get around that in a minute. All right, let's see. There's a couple other commands like this. This one was, I didn't know this existed. search. There's a Podman search command. I learned about this while I was prepping for the episode. I usually just go to the registry that I care about and search there for a container image. But if I did a Podman search for, I don't know, what do you want me to search for? We could search for HTTPD, right? If I search for that, what this does is it goes out to the registries that are defined within Podman, and it finds all the containers that match that search command, or all the container images. Like I said, I didn't know this existed. So if I wanted to go get registry.redhat.io UBI9 HTTPD24, which I think that one would require a login to get, but there it is. I could go get it if I don't know what container I'm looking for. This would probably be a lot more useful if you're talking to a local registry that maybe only has a handful of images in it, or a handful of images. There's not as many name conflicts as there are with HTTPD, right?
And one other thing, so Podman comes predefined with some registries inside of it.
Mm-hmm.
Red Hat's registry and Docker being the two main ones. And so if you just use a short name, like maybe just do Podman pull HTTPD, it's going to ask you which registry to pull it from. Or I guess for you, it'd be HTTPD-24.
Yeah.
Which registry to pull from, and you can actually like select it off the list.
JScar in chat has asked me to search for CTFD because I'm pretty sure that'll have less. Oh, there's still quite a few. But actually, this is a good example. What if I'm going to do Podman pull CTFD, right? Now, what it should do is, it doesn't know what registry I want to get it from. And it's just making assumptions, right? I bet there is not a registry.access.redhat.com CTFD container, right? It's just saying, do you want to try that one, right? So exactly, if I wanted to pull CTFD, I would have to know which registry is defined that has it, or I would have to specify it with Podman. With Docker, it just goes to Docker Hub. So if you're doing a Docker pull, then it'll probably just go get it on docker.io, right?
Yeah, and there's a config file where you can like define what registries are in there and what order they're checked. So if you want to default to Docker first, you could do that. So that's like beyond the scope of our episode today, though.
Right. So two more I wanted to cover before we move along, and that is Podman image list. This tells me what container images Podman has pulled and stored locally. Podman actually maintains a local registry, and every time you pull an image, it goes into your local registry. You call it directly, it'll assume, right? If I do a Podman run on Nginx, it'll assume local, right? But if I wanted to say, for certain, I want it to run my local Nginx one, I would say localhost/Nginx, right? And it'll run the local one. If I've built a local container image, then I would say localhost/container image name. And then it would make sure it would get the localhost version of that image instead of trying to go out to my registries. So just keep that in mind. It's always best practice, if it's a container image that you've built locally or that you want to run the local version of it, precede that with localhost/ and then the image name. So along with image list, you can do things like, oh, I don't need the UBI container image anymore. So if I do a Podman image RM, then I give it this image ID. I could probably do the registry.access.redhat.com / yada, 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 yada. But it's easier with the container image ID. Now it'll remove that particular one from my registry, my local registry. If I had a container defined that used that image, it would stop me and not allow me to do that. So keep that in mind. If you get an error that says a container exists, then you have to delete that container first. Now, if I do an image list again, all we have left is Nginx. And I guess I did miss one. We skipped over it because we got kind of off track. Once you've stopped a container that you don't want to run anymore, right? Let's say we're done with Nginx. We don't care about it anymore. Podman RM Nginx will remove that container, right? So that container definition goes away. And now if I wanted to, I could delete the image. There's another command, like a subcommand for image called prune, which is a cleaner way to say, like, old container images that I haven't used in a while, or maybe older tags of a container image that aren't in any defined containers anymore, that'll clean up all those old images. So if you did a Podman, if I spell Podman right, if I did a Podman image prune, it even gives me a warning. Are you sure you want to do this? It removes all dangling images. And if you tell it yes, then it would clean stuff up. I don't think it'll get that Nginx one yet because we just used it. I think there's a timeout, essentially. Like if you used it recently, it won't remove it. Or if it's the latest version of the container, I don't remember what the exact criteria it has to meet for prune.
So Nate, I wanted to return to one option from the critical path.
Sure.
Your first container that you ran in the critical path was the UBI one.
Mm-hmm.
In that invocation, you used an option called -rm.
Yes. Yeah, so --rm will tell it once this container stops, delete it, right? And that's great for testing purposes, or in that case, it was a container I knew I was never going to run again. I was only bringing up a shell to show you guys around what was inside of it. What that does is as soon as I exited that container shell, the container shut down and Podman deleted it. If I ran it in the background, then it would be safe until I stopped the container. As soon as I stopped it, it would delete it. So it's really good for, I just need to run a thing to test something and I don't want to have to worry about deleting it later. You probably don't want to do it on the containers you really care about because then you'd have to redefine them every time. Unless that's what you want to do. Maybe every time you start that container, you want it to get the freshest copy you can. If you add that RM, it'll delete the existing container every time you stop it.
Thanks for
it's a new mind, like it's a whole different mindset than you treat with like a virtual machine or a system you've lovingly handcrafted, right? You have to be comfortable with these things being blown away at a moment's notice. Okay. Any questions we need to touch on before we move along? I don't think there are. All right, so our next demo then, we talked about that persistent data and how it goes away, right? How anything that wrote to that container will be deleted if you delete and restart that container. How do you get around that? Well, you get around that by passing in what's called a volume within Podman. Now, there's a whole bunch of more advanced ways to make volumes than what I'm going to show you right now. Like you could point a volume at an NFS share, right? Or you could, well, there's a few ways you can do volumes. What I'm going to do is pretty much the simplest way I know how to do a volume. And that is when we invoke the container, there's a command line argument that says simply map this directory to that thing within the container. And that's the -v flag. So first we need to do a little bit to set some stuff up here. Let's see. Yeah, let's do a make dir for, I don't know, let's just call it app. And then inside of the app directory, we're going to make an index.html file. And I don't know, we're just going to do like, oop. Wow, I can't type. And I'm sure that really matters, whether I typed business E correctly or not. Manager Scott will come and dock my pay. Okay, now it's just super businessy. And that's just an index.html file. Now we're going to stand up a container that maps that particular directory to a directory inside of our container. Okay, so we're going to do podman run again. We're going to do that -d like we talked about. And then I have this new flag here, -v. And what -v is doing is it says inside of the working directory, there's a subdirectory called app. We want to pass that through to user share Nginx HTML. And that just happens to be where this container stores its web root because it's an Nginx container and because that's where the container was configured to store its web root. The :z is important, at least the first time you run it, because what that does is it forces the system to fix the SE Linux contexts on the file system in the host so that the container is allowed to read that particular subdirectory. Now, you could do that manually, right? It's like container file T, I think is the context you need to set it to. But it's a whole lot easier to just let Podman do it for you, right? And I can show you what that looks like after we run this. And then the dash P we talked about before passes in that port. We're going to give it a name, my Nginx 2, because I didn't want to worry about trampling other containers. And docker.io Nginx, right? So we're going to run this. And then if we do a podman ps, there it is running. Now, if I do an ls, z, and then d, I guess, for app, it'll show us that it fixed the SE Linux context to container file T, which is exactly what I was talking about. So you, like I said, you could do that manually with SE Linux if you wanted to, but I just think this is easier. Why would I not do it this way?
Well, I noticed also you'll see a couple different SE Linux fields that maybe you have not seen before, specifically the sensitivity and category.
I've never worked with those fields.
So, there are a bunch of places where those fields can be used. But what we're using them for here is to make sure that other containers don't get access to this container's mapped content.
There you go.
So even though you have, it basically is like tightening the sandboxing to make sure that this thing is only available to that container that's running and accessing it. But Nate, I think this ties into something that you said earlier in the episode, which was how to handle dynamic data across container images or container runtimes.
Yep.
Is this how you would do that?
Yeah. So if I were to delete the Nginx container and make a new one, then this particular volume would persist. Same concept, right? If I mentioned before, you can map those volumes to something external like an NFS share. If I had 2 or 3 Podman hosts that all need the same application data, and they're not going to trample each other, right? Your application has to be written to be aware that other instances are using the same data. They could all map to the same NFS share and get the same data and run the same application, which is really handy if you're trying to run things at scale, especially if you're using like something like an OpenShift or a Kubernetes, which is, again, more advanced than we're going to talk about today. But if you have more than one system that needs to access the same data, this is a good way to get that done, or more than one container, I should say. All right, so now that we have it running, let's see that it worked. It should say it's super businessy, right? There we go, super businessy. Now, if I were to make a change to that index HTML file, right? Now we've got some more business to put on our website. Now, if I'm not restarting the container or anything here, if I now use curl to check the website again, it should have my changes. So there we go. So you can see how this would be a lot more convenient. The other way to do this is to make your own container image and copy your website data into the image, which has some advantages, right? It makes it more portable, easier to stand up a new instance of your website. But if the data were to change for some reason, you'd have to redeploy all those containers. So there are cases where this makes more sense, especially where this is not a website, but it's like a database, right? Something that you would not bake into a container that is supposed to be dynamic and very application specific, right?
Yeah, and I was just going to mention that, like, if your database of data can be very large, and so if you were to stick that into your container, it would be a very large container. So now you can kind of separate your data layer from what you're storing and accessing from the application layer, which is like the version of Postgres you might be using, right? So you could upgrade the version of Postgres you're using, but still have access to the same database contents on that Postgres database underneath.
Right. And I'm really itching to talk about other ways that all that stuff works together, but it's a little more advanced than a basics episode. All right. So, yeah, we've covered how do we run a basic container, what's immutability all about, what's in those container images, and of course, how do we make data persistent? And of course, all the little commands and whatnot you've learned about Podman along the way. So, I hope I hope we've covered the basics. What do you think, Scott?
I think so. There was one clarification that Conan Kudo asked about in chat, and Rick put a great explanation in chat about as well. So when you wanted to relabel your thing with SE Linux context, you use the capital Z. And so Kudo asked, well, I've seen capital Z used and I've seen lowercase z used. What's the difference? And so capital Z makes a private label that we saw with the context categories.
Okay.
So this container can access it. A lowercase z sets the context such that other containers could also utilize this. So it's like, do I make this bind mount that I'm attaching into my container private and only eligible for this one instance of the container? Or do I make this bind mount eligible to this type of container and other people can have it bind mounted into their runtime environments as well? So that's the difference. Great explanation there, Rick. Thank you.
And that's why we have Red Hatters in chat.
All right. So I think we've run off the end of our prepared remarks. Man, we went into a lot of depth about Podman today. Like, I don't think any other Podman episode I've seen on the internet goes into this much depth on Podman. And I know that...
And only the one ad for people that can afford the beard care.
That's right. Supporting Nate through his beard care Patreon.
Man, if someone sends me $1 million, you're going to get an email later. I'm just telling you.
Don't send Nate $1 million for beard. But we had talked about building containers before the episode, and specifically we chose to not show that, right? Because we wanted to go into like super deep what Podman things, all the different commands that you could use with Podman, like managing images and managing container runtimes and restarting and stopping them and all the other things. So, man, super deep today. Maybe we'll cover some of the other container things in more depth at another episode, but that's not what we're doing next week.
We do have other episodes where we have talked about things like pods and how you share data and like we've had a bunch of Podman episodes. This one we very intentionally wanted to be about the basics and getting familiar with Podman.
But next week we're not going to be talking about containers. Next week we are talking about something else. Do you remember, Nate? Because I've forgotten.
Something Linuxy.
Yes. Okay.
We totally planned this, and I don't remember either.
And then we neglected to actually write it down. So we'll have another show next week. We know what it is, and hopefully remember, and we'll be able to tell you what it is.
Yeah, we didn't write it down. We have the stub of an episode. There's not even a title on it. So whoever that Nate and Scott on Monday were, man, I disapprove of them.
Past Nate and Scott, terrible people. However, we did talk about what the super fake advertisement is going to be for next week's episode. So I think
that's planned.
That one.
That's totally planned. So yeah, stick around for that.
So and next week is going to be episode 159. And why that's important is that no one else knows this except me and Nate. But we have a call it a fun rivalry with Ask an OpenShift Expert. They're like the longest running show at Red Hat, and they have 158 episodes as of next week, and we will surpass them with 159 episodes. So
the important question is, does Ask an OpenShift Expert know that there's a competition?
I don't know, but when we get that fantastic trophy for being the most prolific show at Red Hat, we'll see.
Least likely to give up. That's our trophy.
Maybe Johnny and Andrew will be like, wait, there was a rivalry? Who knew?
Okay.
All right. So, folks, thanks for joining us. Next week, we will have more Linuxy things on Into the Terminal.
Something great. It'll be awesome.
See you, everyone.
Have a great one, folks.